All right, here we're going to look at section 1.1. And our big essential question, just the kind of thing we want to think about as we go through, is how can you use dynamic geometry software to visualize geometric concepts? And I'm going to show you several different softwares this year while we go through geometry that you can use to help you see what we're actually talking about and looking at. So first thing we want to talk about is our learning targets. These are the big things that we're going to focus on in this section. First, we're going to name points, lines, and planes. The second thing we're going to do is name segments and rays. Thirdly, we're going to sketch the intersections of lines and planes. And then finally, we're going to solve some real-life problems involving lines and planes. So let's look at our first core concept. So this core concept is definitely something that you need to put in your notes and go back to and refer to. So the first thing is these are some terms that we need to just know exactly what they are. So a point, the first thing is that a point has no dimension. It doesn't go in any direction, it just is kind of there. And so we represent points by a dot. A line has one dimension, right? Because a line goes in one way, it just kind of goes back and forth in the one direction. So it has one dimension. We represent it by a line with two arrowheads. So you'll see here that I have arrows on both sides. And when I write it out and name it, it's literally line AB. So I have to have those arrows on the top for it to be a line. So in order to name a line, I have to have any 2 points on that line, and that will help me name it. So then the third thing is a plane. A plane has two dimensions. So a plane is, I like to think of a plane as like the top of my table, right? Because it's kind of a flat surface and it goes in 2 dimensions. Okay? But it keeps on going forever and ever and doesn't end. So here we can see this plane here. So to name a plane, I must have 3 letters and 3 points on that plane. So this plane would be ABC because those are 3 of the points on my plane. You can see over here this M, this plane is also labeled over here as its own thing, so I could also call it plane M. Okay. So now here's our first example. We are asked to give 2 other names for line, and I know it's a line because of this, with 2 arrows, PQ, and plane R. So then name 3 points that are collinear. Collinear means they lie on the same line. And then we have to name 4 points that are coplanar. And again, co meaning they're on the same plane. So 2 other names for line PQ. Let's first find line PQ. So here I see P and Q. So it's this line right here, right, that we're talking about. So what are some other names that I could call that? Well, I see that P and Q are the only 2 points on there, so I could call this QP, and I have to name it a line, so I have arrows on top, because the line goes in both directions, so this could be QP. I also see up here that my line has been labeled for me, and it's been named, so I can go ahead and call that line N. So now I've answered part A. So part B, name 3 points that are collinear. So let's find a line that has 3 points. So I'm going to look at this part right here. And that's not a very straight line. It's hard to draw on this. So I see that S, P, and T are all on the same line. And I know that for sure because they've actually have the line drawn through them. So I can say for this part that points S, P, and T are collinear. So now I'm asked to find 4 points that are coplanar, so along the same plane. Well, I'm going to go take that line that I just used with points S, P, and T. I also see that point T, or point V, is on that same plane. So all I have to do for here is I have to add point V in. So now I have my points that are also coplanar. So this is your first monitoring progress. So you'll see a diagram in your book that you can look through and give some other names for some of these things that you're looking at. Okay, so here's our second core concept. These are just some other terms that we're going to be looking at. So our first one is segment and ray. So first we're going to look at a line segment. So a segment has endpoints, as we see here. So it does not continue past these points, but the points are their endpoints. So I write that kind of similar to like I did with a line, but I don't have arrows on top because this little piece tells me that it ends right at these 2 points and I don't keep going. And you see again that I can go from A to B or I can go from B to A. Those are the same thing. So now let's look at a ray. So a ray actually is a little bit different. So a ray continues on in one direction, but it ends at the other. So here this top ray, since I end at A, you'll see right up here, the end point is at A, but it continues on past B. So down here I see I have B, that it continues on past A. So that would be the second part right here. So now let's look at some opposite rays. So if point C is between A and B, then CA, right, so going from C through A and from C through B, those are called opposite rays. So here is example number 2 in your book. So first we're going to give another name for line segment, and I know it's a segment because I don't have any arrows on top here. So segment GH, let's start there. So I see that is right here, segment GH. Well, I know that I'm dealing with a segment, so I know that I have to have my endpoints here, so that I could also go the other direction though. So I'm going to have segment HG would work for this first part. So now let's look at part B. So name all rays with endpoint J. So first I'm going to draw a little, here's endpoint J. Which of these rays are opposite rays? So when I'm writing a ray, right, I always start and I have an arrow on one direction. This endpoint is going to have to go on J because I was told I'm looking at endpoint J. Well, I see I have a JE, I have a JG, I have a JF, and I have a JH. These are all the different rays with endpoint J. And I can see that G and H are opposite from each other, so these two are opposite rays, and these two are opposite rays. So now here's your second monitoring progress. Again, look at this diagram that's given for you and see if you can follow along and do the problems we just did. So now we're going to be looking at those intersections, right? And that was our next learning target, was dealing with our intersections. So we're going to sketch a plane and a line that is in the plane. So the easiest thing to do, right, is to kind of sketch my plane, and I think of a plane as like my tabletop. So there's my plane and a line that is in the plane. So I know that for a line to be in the plane, it has to have arrows on both sides, and it has to have a couple of points with it. So there's the line that is in my plane. So this would be part A. So let's look at part B, a plane and a line that does not intersect the plane. So again, I have my same plane, but since this line doesn't intersect, it's going to be way out here and not actually touch my plane. So here is my plane and a line that does not intersect. So looking at part C, so sketch a plane and a line that intersects the plane at one point. So here you'll see in part A that this line intersects the entire length of the line because it'll keep going forever, but so does the plane. So here I have my plane, but I have a line like going through it, like it's stabbing it. Okay, so there's my 2 points. So here I have a line that's going through my plane at one point. So here we're looking at example number 4. So I'm sketching 2 planes that intersect in a line. So I know that for 2 planes to intersect in a line, I have to have 2 planes, and then they just have to intersect. So I like to think of this as my flat table, right? So here's kind of my flat table. And we're going to think that this is a plane that I'm just looking at the very top of. So this very top goes on and on and on and on and on forever and ever and ever. So that would be then intersected by another plane that's going up and down. So this entire place where they intersect would be my line, the entire length. So this picture that I've drawn looks at this going at the end, which there would not actually be an end, so we've sliced both planes and we're looking through it that way. Okay, if you look through your book, there's also a really great picture that shows what this really looks like. So here's our next monitoring progress. See what you can do for these ones. Now we're going to solve some real life problems. That was our final learning target. So this is example number 5. So the diagram shows a molecule of sulfur hexafluoride, the most potent greenhouse gas in the world. Name 2 different planes that contain line R. So here I see is line R. First, we always have to find the line that we're looking at. So I have to come up with the planes. And remember that a plane consists of at least 3 points. So I'm going to have to come up with at least 3 points that also contain this line. So first I want to think of like a box, right? So I'm going to draw just my simple little box. So here I kind of have my different planes set up. I've got one going up and down in this direction. got one going up and down in this direction, and I've got one like flat, so the top or the bottom. Those are the 3 planes I'm really looking for here. So I want to use the points that are definitely on line R, right? Because remember, I have to have 3 points to make a plane. So I know I'm going to be using points D and point F. So now I just have to find the other points that will also make my plane. So the first plane that I can see is I see that I have this flat plane, like the top of a table, right? So if I was to lay this down, this would be the top. That would also include this line, G, E, or line Q. So I can go ahead and pick any of those points, either G or E, that would give me one of my planes. So there's one plane. So to find my second plane, I know I have DF again, but this time the other plane that contains this line is the one that's going straight up and down, like the screen of your computer facing you. So I see it also includes this line here, okay? So points A and C. So I can use point A to label my plane. So my 2 planes here are plane DFG and DFA. And you'll notice when we're naming these planes, there's several different choices we can use because we could pick any point on those planes, okay? So your planes may be slightly different. So here's your last monitoring progress. See what you can do here. So now let's go back up and review our learning targets to see how we did. So first we looked at how to name points, lines, and planes. The second thing we did was we named segments and rays. Thirdly, we sketched some intersections, and this is going to be hard to do, so make sure that you're able to actually see it in your brain and know what you're talking about. And then finally, we looked at some real-life problems involving lines and planes. So now that we've worked on these, go ahead and work on your homework for this section.